Welcome to the video tutorials of the book Methods, Evaluation and Research in Education by Mohammad Aktaruzzaman. And today we're going to learn how to do two-sample t-test in SPSS. In fact, this is an inferential statistical test. In two samples t-test, the t-test is applied to two groups of individuals or one sample, which is divided into two parts based on some characteristics. For example, gender. Let's go through an example. There are 60 students in a class and 20 students, amongst them are 10 male and 10 female, out of 60 are selected as a sample. A researcher has administered an IQ test of the selected 20 students. The results of the test are kept in a file two samples t-test. Considering the above scenario, now we're going to test the null hypothesis. The null hypothesis is there is no significant difference between male and female in terms of their level of intelligence at 0.05 level of significance. Let's see the SPSS data editor window at the screen. Now, go to File, then open Data, and then Data File under SPSS Evaluation folder, and open the file two samples t-test in the SPSS data editor. Just have a look at it. It's already opened. The file is shown in SPSS editor in the data view. Let's see the variable view of the data. There are two variables, score and gender, which are of numerical type, and the scales of measurement are scale and nominal, respectively. In the values column, you have to define the gender, like male as 1 and female as 2, for example. Go back to the data view of the SPSS data editor. You see the variables at the top of each column and also see the scores of 20 students, both for male and female. The pattern of data view is different from the usual one. You can change the data view pattern by clicking the value labels icon, which is third from the right at the toolbar just below the menu bar. Now, go to Analyze menu. Just go to Analyze menu, then Compare Means, then Independent Sample t-test, which is in fact two-sample t-test. Take the score of the test in the test variables field and also define the grouping variable by taking the gender of the student in it and labeled group 1 as 1 and group 2 as 2. This is because in the data 1 is denoted as male and 2 as female under the gender variable. Now, press continue. At the same time, select the Options button and specify the confidence interval as 95%, which is already there as default value, and it implies 0.05 level of significance. Click Continue and then OK. See the output at the screen. Let's have a look at the first table, Group Statistics. The number of students, their mean and standard deviation are shown here with respect to male and female. However, from this table, it's not possible to draw any conclusion about the hypothesis. Let's see the second table called Independent Sample Test. In this table, there are two sig values. One in the Levin's test for equality of variances, which is 0.696, and another one in the t-test for equality of means, which is 0.034. For testing the hypothesis, SPSS needs only the sig value to be compared with 0.05. Remember, the sig value generated by SPSS and this level of significance is completely different. In SPSS interpretation, sig value greater than 0.05 means acceptance of the null hypothesis, And on the other hand, sig value less than 0.05 means rejection of the null hypothesis. In case of equality of variances or homogeneity of variances test, sig value 0.696 is greater than 0.05, which implies the null hypothesis there is no difference between variances of the group is not rejected. It indicates that the variances are approximately equal. In case of t-test for equality of means, the sig value 0.034 is less than 0.05, which implies the null hypothesis is rejected. That means research hypothesis is accepted. So, there is a significant difference between male and female in terms of their level of intelligence. And this difference cannot be attributed to chance factor. Now, with the help of the table, group statistics, it can be easily said that male is better than female in terms of their level of intelligence. In this test, the level of significance is 0.05, which is equal to 95% confidence interval. It means if we repeatedly draw samples from the population and calculate the mean for each sample, we would expect that 95% of them would fall between the lower and the upper 95% confidence limits. However, using the t-value, degrees of freedom, level of significance and type of test, two-tailed or one-tailed, you can do the same interpretation manually. The details of it are described in chapter 10 of the book, so just check it out. Hope you've understood the two sample t-test. Now, you can practice yourself on different datasets to gain better understanding. Thank you for staying with us. It's Yazdani saying you goodbye.